Hello everyone. This question has been taken from Olympiad Pathfinder, multiple choice question number 35, chapter number 2. The question is, in the setup shown, this is the setup. A block is placed on a frictionless floor. This floor is frictionless. The cords and pulleys are ideal. These cords through which the springs and pulleys are connected are ideal. And each spring has a stiffness K. The block is pulled away from the wall by applying a force. How far will the block shift while the pulling force is increased gradually from 0 to a value F? So first thing is pulleys are ideal, means pulleys are massless and frictionless. Cords are ideal, means cords are massless and inextensible. The applied force is increased gradually from 0 to a value F, means all the time the whole system is in equilibrium, means there is no acceleration of the block. Only it is shifting but without any acceleration. The question is asking when the force reaches to a value of F. So what will be the travel of this block from this position when the force has risen to a value F? There are 4 options given, A, B, C and D. So we must solve it. We must calculate it and select the right choice. Here I have given the write-up. In the write-up it is given that frictionless surface as per the question. Ideal pulley means massless and frictionless. Ideal cords means massless and inextensible. So you should also write inextensible. Force applied is increased gradually to F, means the block is being pulled under equilibrium till that force magnitude rises to F. Spring constant for each of the spring is K. Let us give the name of these springs as this is number 1 spring, this is number 2 spring, this is number 3 spring, this is number 4 spring. So when the force has risen to the value F, we have shown that x1 is the extension in spring 1, x2 is the extension in spring 2, x3 is the extension in spring 3, and x4 is the extension in spring 4. Okay. If we take this section C from A to B, how is this spring and cords are connected? So here the cord, then spring, then the cord passing over the pulley, then again passing over the pulley, again connected to a spring and again the cord. Okay. So this is basically, we can take it as one entity. Okay. So if the tension in the cord is T, it will be throughout T because the cord is massless. Okay. So we will take this section. We have shown it over here. So at this end in the cord, the tension is T. Spring has got an extension x1. So a spring will try to pull this end this side with a force K x1. Okay, so these are the forces which is acting on the point C. Okay, but the point C does not have any acceleration or okay. So T is equal to Kx1, right? So we will, if we write the force of equation, T minus Kx1 will be equal to 0. So that is T is equal to Kx1. Similarly for this section in spring 4 connected to B point, and this. And this is, if we take this as D point, at D point which all forces are acting? T is the tension force. The spring has got an extension at Kx force, so Kx4 will be the force by which the spring will be pulling this point, this side. Okay. So we will write an equation of motion for point D. So T is equal to Kx4. Okay. So T is equal to Kx4 is equal to Kx1. That is what we have shown here. So therefore x1 will be equal to x4. So whatever extension is happened in number 1 spring, the same extension will happen in number 4 spring. Now we will make the free body diagram of number 1 pulley. So in number 1 pulley, both sides are cord, and cord is having tension T, and that is equal to Kx1. So T acting on this side, and here it is connected with the spring. Because of the spring, the force is coming Kx2. This end is connected to the spring number 2. Okay. And spring number 2 has sustained an extension of x2. So because of that, the Kx2 will be the force acting on this side on the pulley. So if we write the equation of motion for this, Kx2 will be 2 times Kx1, right? So x2 will be 2 times x1. So extension in spring 2 will be twice the extension in spring 1, right? This is number 2 equation. Similarly, we will go for pulley number 2. So pulley number 2, if you see this side is cord, and cord is having tension T, so Kx1, right? And here it is connected with the spring 3. The pulley is connected with spring 3. So this side it is acting Kx3, right? So Kx3 will be equal to 2 times Kx1. So x3 will be 2 times x1. So that is why we can show that this is Kx3 is equal to 2t, right? For the block. Now we should write the equation, show the free body diagram of block. On the block, this side, because of the spring, the tension is Kx2. And Kx2, we know that x2 is 2 twice x1 here, 2 times Kx1, so that is 2t. Here it is, the tension T is acting because this is point C, A to C is the same unit, right? So T is equal to Kx1. So F is equal to, from this free body diagram, you can see F is equal to 3 times Kx1 plus 2 Kx1. So that is 3 Kx1. Or x1 will be F by 3 into K. This is equation 4. So let us assume that X is the total, X be the total displacement of block in the horizontal direction from its original position when there was no force. When the system was, when the force started applying on it, right? Showing all the tension, force and extension in a spring, and overall diagram is this. So you can show like this, right? Here it is x1 extension, here it is x2 extension, x2 we know we have calculated already that it is 2x1. Here it is x4 which is also equal to x1, we have calculated here. Here it is x3 2x1, so here this one, so x3 is equal to 2x1. So this point, so this system is having tension T, so this is T. On this side it is 2T because 2 times Kx1, so 2T. Here also it is 2 times T because 2 times Kx1, so 2T. X is the total displacement of the of the block, right? So we will use this equation. Summation of t dot s is equal to 0. This equation is applicable for the when the motions are constrained. Okay. So for the constraint displacements, we can use this equation. T dot s is equal to 0. Work done by the tension force is 0, right, on this system. So with T, what extension is happening here? This is x1. So T into x1 cos 0 degree. With 2T, what extension is happening here? 2x1. So 2T into 2x1 cos 0, because displacement and tensions are in the same direction. Here also 2T is the tension force and 2x1 is the displacement. 2T into 2x1 cos 0 for this. Here it is T into x1 into cos 0, right? But at this end, on the block, from the Newton's third law, since this is pulling it with 2T, so this will pull the block with 2T in this direction. So 2T into total displacement x into cos 180 degree. Same way T into total displacement x into cos 80 degree. So we will get this equation, and from here we will come to an equation 10x1 is equal to 3x. So x will be 10 by 3 into x1. Now x1 we have already calculated before, so from equation we can put the value of x1, that is f by 3k. So x will be 10 f by 9k. And if we go and check in the options, so option D is the right options, because option D is matching with this value. So hopefully you understood the concept of solving behind it. In case any problem in understanding, you can write in the comment box. I'll come back on it. Thank you.